Earth scientists and climate scientists have known for probably close to a century that things like sea level have changed in the past. What we weren't aware of until recently, perhaps just the last 15 years, is that sea level change that's happening now and sea level change that's happened in the past hasn't happened the same everywhere. There's a lot of regional variation. There's also, during periods of time like at the end of the last ice age, where we had nearly 10,000 years of continuous sea level change, we already know that it didn't change at a constant rate. There were periods of time when sea level rose quickly and periods of time where it didn't change nearly as fast. So the types of information that we're trying to pull out of this deglacial sea level record include trying to resolve events that happened over the perhaps 1 or 2 century time period, which is relevant to the discussion today about impending sea level change. Part of the way we're able to get higher resolution out of our records is to be very details oriented. This work involves a lot of different components. There's the field research, there's the lab component, there's a component where we date fossil coral skeletons. We might be able to resolve age differences at the 10-year level. Hawaii and Palmyra are 2 really ideal places to conduct sea level research. Because of their geographic location on the planet, complicating factors that we find at sites closer to the continents, for instance, or in higher latitudes, are really minimal. So it gives us the ability to tease out what are likely to be global effects and what are likely to be local or regional effects in sea level records at other sites. The first part of this research, what we did on leg 1, was primarily a detailed mapping exercise using an autonomous underwater vehicle. It made sonar maps of the seabed, both the shape of objects and their reflectance to sound. And this was important to develop a model of what the seabed looks like over a relatively large and continuous tract of ancient coral reef. So this area is 20 miles-ish long by several miles wide. And we've made past observations there using submersibles, taking samples, and now what we're hoping to do is place those in the context of a broader scale map so we can understand how an entire coral reef responds to sea level change, or had responded in the past. The second leg of this research had 2 components to it. They both involved using the remotely operated vehicle SuBastian. In the first part of the research, we told sites. This was meant to give us some next level information to complete the Penguin Bank whole-reef construction. The second part of this research was exploratory in nature. We have a hypothesis about sea level change that suggested it would be useful to have another site in the Central Pacific, closer to the equator, roughly halfway in between Hawaii and Tahiti. And we picked Palmyra Island and Kingman Reef in the Line Islands because it met those attributes. We didn't know what we would find when we came here other than essentially expecting there to be coral reef at the right depths that represented growth during the last ice age. And we found what we were looking for. So in that sense, I think we really exceeded expectations. In addition to giving us sea level information, it'll also give us information about a slightly different coral reef ecosystem than we have in Hawaii and how both of them respond to sea level change. So what we learned at Palmyra Atoll is that it has a coral reef at the expected depths, a drowned coral reef, that has all the attributes that make it excellent for sea level study. The quality of the samples that we recovered, the details of the exposures that we were able to see give me very high confidence that we're going to be able to add yet another detailed sea level record site to the small number that exist. At Penguin Bank, our objectives were a little bit different because this is a place I've been working at for about a decade. And this is really an attempt to do sort of the next level of understanding, to try and look at an entire reef system and how it responded to sea level change over about a 10,000 year period. But putting all that together and interpreting it in the context of all the images and ROV dives and my past work is going to take a little bit of time. So I don't know what the final takeaway is, but I do know that we exceeded our expectations in terms of the amount of seabed we were able to map and the quality of the maps. So when we talk about making predictions for different places around the world that are going to experience sea level change over the next century, and we're interested in being able to say, will it be 1 meter or 2 meter in your locale? That's the kind of resolution that we're looking for, and that's the kind of resolution that I think people who live in coastal communities are hoping the scientific community can provide for them.